December 2018. The U.S. military detect a huge explosion in the Earth's atmosphere, high over the Bering Sea, off the coast of Alaska.
When an explosion of this magnitude is detected, everyone's mind goes to the same thing, nukes. But when the real answer was found, and it was determined that it didn't even originate from Earth, that was even more shocking.
The cause of the blast? An asteroid.
This asteroid was 30 feet across, something like that, over 1,000 tons. But it was moving at 20 miles per second, over 70,000 miles an hour.
This asteroid was small, and it exploded in the atmosphere over the ocean, so nobody was hurt.
But if it had been bigger, or it had come in over a different place, or it had been moving a lot faster, this could have been a dangerous object. But the scariest thing about it is that we didn't see it coming.
So far, we've been lucky. But near misses happen all the time.
About once a year, we get something the equivalent of a nuclear bomb going off in our atmosphere. And while that sounds horrible, most of these happen tens of miles up over open ocean where we go on completely oblivious.
We may be oblivious to most of the threats from space, but they are very real. We're going to get hit.
Over a certain amount of time, an asteroid impact is inevitable. It will happen, 100% absolute certainty.
NASA considers the threat from the skies so severe, it has made protection from asteroids a top priority.
These events are not rare. They happen. And of course, it's up to us to make sure that we are detecting and characterizing, tracking all of the near-Earth objects that potentially could be a threat. This is not about Hollywood. It's not about movies. This is about ultimately protecting the only planet we know right now to host life, and that is the planet Earth.
To help plan protecting our home, we carry out Earth defense simulations. For 3 days, 200 scientists at the Planetary Defense Conference battle a simulated asteroid 20 times larger than the Bering Sea space rock.
We practice, all right, what if this hits a major city? What would we need to do?
By running potential impact scenarios, we can prepare for a real asteroid strike.
This is like a fire drill that you would do at school or at work, where you practice and think about, okay, what if? Where are the exits? How do I get out? How fast do I get out?
The drill starts with the discovery of a simulated Earthbound asteroid.
So the first information is there's a big asteroid coming towards the Earth. Then we get a better estimate of how big it is, how fast it's going, and where it's going to hit.
The asteroid is heading straight for Earth, with Denver, Colorado in its sights. The Planetary Defense scientists send up a simulated spacecraft to smash into the asteroid and push it off its path. But it's a big gamble.
You can push it the wrong way. You can potentially have unintended consequences.
In the simulation, the spacecraft strikes the asteroid, deflecting it away from Earth. But the impact dislodges a 200-foot chunk, which is now heading straight towards the eastern seaboard.
So there's this one last piece that is now going to hit New York. We know that something that size is going to have citywide consequences. That is huge. That's a horrible impact.
When you're actually in the conference room and you understand eventually that New York City is going to be destroyed, and you're having strategies about how to evacuate people, all the timing. When you're doing the simulation, you're in your head, you're thinking about these things, you're trying to reason them out. But can you imagine the feeling in your gut, right, in your heart, if this was real?
If this were real, the chunk of asteroid would strike Earth's atmosphere at 43,000 miles an hour. As the space rock hurtles down, it collides with molecules in the atmosphere, which buffet the falling rock.
It's kind of like doing a belly flop into a pool, right? You're going from the vacuum of space into the dense lower atmosphere in mere seconds. And that's an incredible amount of pressure to put on the object.
The asteroid slams into the air ahead of it, compressing it violently. The surface of the asteroid gets hotter and brighter.
It's actually the air itself that's glowing luminously from the heating of the shock wave, the world's most intense sonic boom, if you will, that heats the air to incandescence as the object passes through. So that's the source of that brilliant illumination.
This bright burning asteroid is called a bolide. We witnessed one descending over the Russian city of Chelyabinsk in 2013.
All of a sudden, there was a huge fireball streaking through the sky, and people had no idea what they were witnessing because it looked like the sky was on fire. It was insanity.
As the asteroid descends, the compression of the denser air beneath it starts to flatten and even disrupt the falling rock.
There's a high pressure on the front, there's no pressure on the back, and it's being superheated.
And that intense temperature causes the air to glow, which is how we see the streak of a meteor. And it also disintegrates the asteroid itself. It's hot enough to literally melt rock.
This can often lead to them exploding.
The combination of heat and pressure invade the falling asteroid, causing it to blow up.
Most asteroids don't reach the ground before they completely disintegrate in a tremendous release of energy.
This is what we call an airburst, and we learned a lot about these while we were testing nuclear weapons after World War II. Some of these bombs were blown up underground and on the ground, but they found out when they blew up bombs above the ground, it actually did more damage. It was more widespread damage.
The explosion of the Chelyabinsk asteroid sent out a powerful shock wave at thousands of miles an hour. The blast traveled over 100 miles. It damaged 7,000 buildings and put 1,500 people in the hospital.
All of the injuries pretty much came from people who saw, oh, what's that bright flash in the sky? And they came close to a window to look and see what it was, and then the pressure wave hit and blew glass in their face.
The Chelyabinsk asteroid was only 65 feet across. The rock in the defense simulation is 3 times more massive, and it's heading straight for New York City.
Imagine what would happen if an explosion 1,000 times greater than that over Hiroshima hit New York. We're talking about an utter, complete destruction of the city and millions of people.
With so little warning, the only option would be to evacuate New York City.
How do we get everybody out of New York City within just a few days? That's where panic sets in. That's where fear would really become the dominant emotion.
Anyone left in New York City would see the bolide racing in, followed by a blinding light as the asteroid explodes above the city. The blast would be equivalent to the largest nuclear weapon ever detonated on Earth.
Buildings would be flattened, melted. There would be fires for miles around. In the first moments of the explosion, 1 million people could be killed instantly, and many more would die later in the rubble and the ruins of what would happen there.
Everything within 9 miles of the blast epicenter would be completely destroyed. The intense heat and pressure would wreck buildings.
It's the worst possible day for New Yorkers. And not just the city itself, there's something like 15 million people living in the New York area.
The shock wave would race out over 250 square miles.
This would certainly be the worst disaster that the U.S. has ever experienced. We're talking about millions and millions of people displaced, affected within an instant.
This scenario is just a simulation, for now. The asteroid Apophis is heading our way. If it hits Earth, it might not just kill a city. It could kill a whole region.
I wouldn't exactly want to be there when that happens. I want to be very, very far away.
Apophis will skim Earth in 2029. But its path could change, possibly turning a future miss into a direct hit.